In this video, I'm going to go through a quick introduction of RAG. RAG stands for Retrieval-Augmented Generation. Now, if you've never heard of RAG, no worries. That's what I'm going to be doing in this video. The main idea is that when you use a large language model, again, if you don't know what a large language model is, I did a video a little bit ago about large language models. You can find it somewhere here. Okay, but a large language model essentially is a model that was trained on certain data. So for instance, if you go to ChatGPT and you type in what is the capital of France, and of course it will give you the capital of France because it was trained on information about, including in this case, the capitals of countries in the world. But if you were to ask ChatGPT what is the name of my first dog, of course ChatGPT wouldn't know because it's using that large language model, the model that was trained on something that is not related to your information that is particular to you, that is specific to you. And that of course is indeed a problem. And RAG essentially allows us to take our own information, our own data, databases, video, textual information, raw data or unstructured data as they call it, sort of inject to the large language model. So now the large language model has more information, including your own information. And so now when you ask questions related to your specific data, you are able to get the answer from the large language model because it's able to connect to your data that you have injected. Happy day. So you get the right answer. So that is the idea of RAG. So that's what we're going to be doing in this mini course or in this video, and I hope you enjoy it. All right, let's go ahead and get started. All right, so let's go ahead and start doing the deep dive on RAG. So I know that most of you who are here may already know what RAG is, and that's wonderful. But I'm going to do just a quick deep dive overview so that we have some sort of a summary overview again of what RAG is. So we're going to look at what is RAG, the motivation behind RAG, and also advantages. Now, what is RAG? RAG stands for Retrieval-Augmented Generation. So the key points here is that we have retrieval, augmented, and generation. These are the key points here: retrieval, augmented, and generation. So the idea is that we have a system that retrieves information. We have also a way of augmented whatever we are passing through, as well as then push that information into a machine, quote unquote, that will generate a result. So RAG has two main components, which is the retriever. The retriever, what it does, it identifies and retrieves relevant documents. And then we have the generator. Well, it takes retrieved documents and the input query to generate coherent and contextually relevant responses. That's because that is the whole idea, to get coherent and contextually relevant responses. These are the main components of RAG. But we still haven't defined RAG really. So what is a RAG? So the definition will go as follows: a framework that combines the strengths of retrieval-based systems and generation-based models to produce more accurate and contextual relevant response. And we have the keys, again, the keywords: contextual relevant response, because that is the whole goal of RAG. Okay, that sounds great, but translating all of that, we would say efficient way to customize an LLM, a model, language model, large language model, with your own data. Well, what that means is, what are we doing really is that, as we know, a large language model like GPT and many others out there, they only know so much. Okay, so what we're doing is we are injecting our own data into this large language model so that it knows more than the things that it knows that was trained on. So now the large language model is going to know about specific contextual data in addition to what it was trained on. Let's look at an overview of RAG. We have documents. These documents are cut into small chunks, and then these chunks are put through an embedding large language model. So to create embedding essentially, and then that is what is created, embeddings, and those embeddings are set. Okay, so now the question or the query comes in, goes through the same process, transforms to embedding, and then we have this embedding, which then is used to go ahead and find in our retrieval system, in our vector database, most similar items, which then is pushed into a general large language model, which knows how to take that information, in this case, the most similar results with the question, in this case, the prompt, and get the response that is needed, that we're looking for. So that is how a RAG works. Notice here, when we say RAG, Retrieval-Augmented Generation, that means that the generated response is augmented by the data I retrieved from the documents in our case. Hence the name RAG. So really, if you want to do a deep dive into naive RAG, this is what happens. So we have the documents, and these documents are going through the phase of parsing and pre-processing. So essentially, cut them up into smaller documents. This is the chunking process, and then we pass them around into smaller chunks, and those are passed through the embedding model to create vectors out of these chunks. Okay, so we're vectorizing those chunks. And then that is what is saved into a vector store or a vector database. So this is the part of indexing that happens here. Of course, is the indexing part as I have shown you. This is the part where we cut the document and pre-process everything and chunk it up and then create those embeddings or vectorize those chunks and save them into a vector store. And then what happened is then we have a user who has a query or question of some sort, and that also has to go through the embedding model to vectorize that query. And then that is actually what is sent to search into the vector database. So we have vectors and vectors that are easily used in a vector database to do all sort of things, mainly to search. And then the information is retrieved. The relevant documents are retrieved, are packaged up, in this case with a prompt, as well as the relevant documents, as I said, and the query. But notice here, this is the different phase. This is the augmentation phase of the RAG. So we're augmenting, we're adding something to what we had before. So not only we have a query, but we also have really prompt, which is part of the query, and relevant documents, and so forth. Okay? So once that is augmented, we pass that information through a large language model. So it could be any kind of large language model. And then that's when the response is generated, which is then returned to the user. All right, so now you have the basics of understanding what RAG is, how really RAG works. The idea is that we have our own documents. We're going to go through the process of extracting those documents, splitting those up, and then pass them through the large language model. Of course, we're going to be saving that into a vector database. Now, if you don't know what a vector database is, I actually have yet another video where I talk about vector databases somewhere at the top here. Okay, so go ahead and check that out. So we're going to do a hands-on here where I'm going to show you how to use RAG to create a system, a RAG system that allows us to pass through some documents. And in this case, we're going to be a bunch of articles that we're going to be reading in, saving those to a vector database, and then perform RAG to start conversing, or in this case, querying our documents so we can ask questions and get the correct answers along with the large language model. In this demonstration here, I'm going to be using OpenAI, which means that you need to go and have an OpenAI API key for you to be able to do this with me. Now, if you don't want to use OpenAI, you can use other large language models out there, and things will be a little bit different, of course, but the main idea is going to be the same. All right. Okay, let's go ahead and get started. And so I have this project called RAG Intro and have a few things here. One of the important things is that you have here the OpenAI API key. So you need to get that. You need to have that. Then, of course, I have the app.py, which is empty at this point. So this is where we're going to start doing our magic. Now, before we do that, I need to make sure that I have a virtual environment. If you want to learn more about Python, I have a full video of 1 hour or so. You can go ahead and check it out. Also, you'll see somewhere here. All right. Or you can search on my channel. You'll find that. All right. So I have my virtual environment created there. And let's go ahead and say source venv and activate that real quick. So we have that set up. So now it's active. We are going to install a few dependencies. The first one that I need here, let's see, I have my cheat sheet here. So the first one that we need is the python.env. So pip install. I'm going to pass that. This is going to allow us to retrieve information from our virtual environment file. Okay, and then next I'm going to get the OpenAI, because we're going to be using OpenAI. So I say pip install OpenAI. Okay, and because of the nature of large language models and RAG system, we need to save this information, this data that we're going to split up these documents into a vector database. If you don't know what a vector database is, I do have a course that talks about vector databases. And so there are many kinds of vector databases. We're going to be using ChromaDB, which is light and easy to use. So I'm going to say pip install ChromaDB as such, so we have that set up for us. I'm going to go ahead and import a few things that I need here. Now, just to make sure that this is fast, I'm not going to type everything because you should have access to this code. The OS, because we're going to be needing that to access operating system folders and files and so forth and other functions. I have ChromaDB and I have .env here to load all of environment variables. And of course, I'm going and importing embedding functions. We're going to use that to create embeddings, because those are the representations of our data that we need to have in order to put that into our database, vector database. Of course, we have OpenAI here, which we're going to be using soon. All right, so next what we'll do here, I'm going to load all of our environment variables, and then I'm going to set up the OpenAI key from my environment variable, as I said, from our environment variable, from our environment file there. And then what we're going to do is we're going to create the function, the embedding function. This is what it's going to allow us to create those embeddings again. Once we chop up all of our data, which I'm going to show you in a second here, we want to transform that into embeddings, these zeros and ones, a vector space, and then that is what's going to be saved into the vector database, the Chroma vector database. And when you do that, when instantiating this embedding function, you need to pass the API key, OpenAI key, because it needs to know what model it's going to be used to do that. And we're going to pass the actual model name, which is going to be text embedding 3 small. So this is just a very small, light embedding functional system that allows us to create embeddings. And next, I'm going to go ahead and, of course, initialize the Chroma client persistence. So I want to be able to persist, or in this case, I want to be able to save the actual database. Now, looking at the data here, you see that I also have these news articles. So this is where I have all of these articles, news articles that I found online. This is what we're going to be using as the documents. And then we are going to chop it all up, put it into a database, right? Not a normal database. This is going to be a vector database. And then we're going to use other techniques to start conversing, talking, and getting the documents that we need to answer the questions that we are asking. So what are we doing here? We are initializing the Chroma client. You can see it's very simple, really. You say Chroma persistent client, and then we pass the path we want this to have. Now I said Chroma persistent storage. This is kind of long, but you can make it shorter if you want. And then the collection name, we add whatever name we want. And then now we actually say Chroma get or create collection, which means this function allows us to create the actual collection. Collection is just a table or a document where we can put all of these documents, or tables in this case, okay? And then we need to pass the embedding function. Notice that now we are passing what we initiate or instantiated at the top here, the actual OpenAI embedding function that is going to allow us to create those embeddings, right? The vector embeddings along with the collection name. There we go. So now we have this collection that indeed we created with Chroma. All right, so let's go ahead and create our client. This is our OpenAI client. We pass the API key and the OpenAI key, of course. So now we have our client. We can do all sort of things, meaning we can, for instance, say client dot, I think it's chat dot open, what is that called? Completions, and I can go and create, and then here I can pass a few things such as the model, I believe. Let's say model, and I can say GPT-3 Turbo, and I can pass messages and roles and everything. In fact, let's just do that real quick here so you can see this client working. You can see we have the messages, and the system says you're a helpful assistant. What is human life expectancy in the United States? Well, that's pretty good. Let's go ahead and see if this works, making sure that you have everything set up, of course. So I'm going to say print. Actually, let me put this, say res or resp like this, and say I can say resp like that, and I can go to choices and go to message and they get the content. All right. So if I go ahead and run this, I should be able to get something. So Python like this. So should let us know that indeed we have everything set up, and we should get some results in a second. Okay, looks like we have some issues here. Resp, choices, message. Let's just go ahead and get the response, the whole payload. I think I'm missing the actual object. It's okay. Let's run again. Okay, so we can see that we have the response chat completion, and went ahead and got, as of 2020, the average life expectancy in the United States is around 78.8 years old, and so forth. Okay, so we're getting a payload to tell us that this is actually working. Okay, of course you can get to the actual payload if you want this content here. If you go through, I can go straight to content, I believe, like that. Okay, same thing. Go ahead and run. We should get the actual content, I think. Okay, there we go. So now we get the actual content as of 2020, blah, 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 and so forth. Okay, so at least we know that this is working. That's all we really wanted. That's not our end goal, so I'm going to get rid of that. Okay, so the first thing we need to do is, of course, to load our documents from our articles. As you can see here, we need to load all of them and then start doing something. So I have all of the code already so that we don't spend too much time, and you'll have access to all this code anyway. And what I'm going to do, it's a function that I created before this. So what are we doing here? We're loading documents from a certain directory. So I have a print statement here just to give us what's happening. And I go through, in this case, I know that all of these articles documents end with txt. They are txt files. It's kind of hard to see. You just have to believe me. You can see here, they are txt files. Okay, so that's what we're doing. We're going through and start loading all of them and return the actual documents. Right? It's going to be a list of documents. All right, so the next thing is we need to split these documents once we get them. We're going to have to split them up so that then we can pass them through into our database. So I already have a function that does just that. You can see we pass the split, the text, and we say the chunk size is 1000 and the overlap is 20. The overlap essentially says once we split these documents, we want to make sure that they overlap, right? Overlap like this. That way the contextual meaning of each piece of text is overlapped, which means it's kept. The context is kept, because once we split all this up, these documents in small chunks, they're going to be very distant. So the more overlap we have, you can see that the more context we'll have kept. The less overlap. So that is the idea, really. And so we just go through the splitting process and then we return the chunks. Okay, so we have those functions we're going to be using soon. And so now we're going to go ahead and load documents from the directory. So the directory, as you see here, is, let's see, right. I should have said news articles. Okay, so I'm just going to remove this like that. Should have put under data, but it's okay. So is under news articles, which is this guy here, and it's going to go ahead and get all of them. And then for your documents, I'm going to go and then I'm going to call load documents from directory, pass the path, which is this one here. And at this point, we should have all the documents. I'm going to go ahead and print real quick here so we can hopefully see. We should have the length of the documents once we have those documents loaded, right? So in this case here, you know that this should return a list of documents because documents is indeed a list. Okay, we should have something. So let's go ahead and save this, and I'm going to quickly run again. Okay, loaded 21 documents. Very good. So it went and got all of those documents that we loaded in. Essentially, all of these documents here. So they're about 21. Now, once we have these documents, of course, now it's time for us to do something else. What we need to do really is to get those documents split up. So I'm going to go ahead and do that. So now I create this split documents into chunks. So I have a list and I go through those documents that we just received, and then we call this split text. Split text is indeed what we have here. So it's going to go through and return another chunks, which is a list of all those documents that are split. But remember, we have this overlap for each document to continue having the context. Okay, very good. So we do all that stuff, and then I can go ahead and say print again split documents. So this should give me all of the documents chunks, split documents into the length of chunks, okay? Because I should have something at this point. Let's run again. Okay, so you can see it went through the process, splitting docs, and this is telling me how many splits I got, because that is what indeed I asked, length and so forth. Okay, so we know this is working, which is essentially what we want. Okay, so the next function I need here is a function that will generate those actual embeddings. Because remember, once we split up all the documents, we need to take those splits that we did here and create embeddings. This is what's actually saved into our database, into our vector database. So I have a function here that is going to be helpful for us to use. So essentially what this does is we use OpenAI to create those embeddings from the text. Okay, that's what we're doing here. So you can say client, embeddings, and create, and we pass the text, these pieces that we are putting through, and then we say the model that we want to use to create those embeddings. That's all we're doing here, and then we get those embeddings and return them. Okay, this is going to be helpful in a second here. Then I'm going to generate the actual embeddings. Why? Because I already have the function. So to generate embeddings, we go through all the chunked documents. Yes, you remember these guys here. And then as we go through, we call these get OpenAI embeddings, and we pass the actual information through to then create a document embedding field. So each time we go, we're actually creating those embeddings. So we can actually print to see our embeddings. So I can say doc embedding, and what will happen is, let's go ahead and run real quick so you can see. We're going to go through the whole process, splitting, and look at that. It's creating those embeddings. It'll take a bit, and in a second here, we should see actual embeddings. So after a little while, so be patient, but this will take a while. You can see now we have the embeddings for vector spaces, right? And so there we go. Of all the documents, now we have all the embeddings. This is these vectors that actually we're able to then add to into the database. So this is good. So I'm going to go ahead and clear this. So I just wanted to show you. Okay, so now that we have our embeddings, let's go ahead and comment this out so we don't run that. Let's go ahead and insert each one of these embeddings into our database. Okay, so of course I have the code for that. So for each one of these, we're going to, because we know these chunked documents, which is what we have here, it has all of the information. What we do now is that we're going to get those chunks, the real chunks, before we embed anything, add into our vector database, and at the same time, we're going to add the actual documents along with the embeddings. So now we're going to have these chunks of the documents, these little pieces, not embedding. These are just the text chunks. And then we're going to have the actual embeddings. They are going to be sitting on our database. Oh, very cool. Then we're going to create a function to query our documents. So I have all of that, and I'm going to just copy that and put it here so we don't have to do all the things. So the idea here is that query documents. And now this query documents is very simple. We pass in the question like, tell me about GPT-4, something like that. Anything pertaining to our data that we've just saved, okay? And then we say how many results we're expecting to receive, how many documents essentially. Because what will happen is we're going to be able to retrieve the documents corresponding to the query that we're passing in, right? So in the background, what will happen is the database is going to be able to go and search, do similarity search until it finds what is congruent with the question that we have inserted. That's pretty cool, right? And so we say in collection.query, passing the question and the number of results we want, documents that we want, and then we put in a variable. And then we extract the relevant chunks from that, from our list of documents. Because this result here is going to have the list of documents. That's why we can go through those documents and get the relevant chunks. And then once we have them, we just return those relevant chunks. I have this other code here. You can check it out. This is going to just give us the distance between the relevancy. So essentially tell us how close to the actual answer these documents are. Okay. And you can play with that. Okay, so next, what we'll do once we have this done, I'm going to then, of course, have a function that will generate the response. Because think about it. We have taken the documents that we have, we chopped them up, we created a vector database, and then we put inside of that vector database. But before that, we were able to create embeddings because we want to save those embeddings because it's easier for the search to happen, right? For the right document once we ask the question. And so now we want to generate the actual response. So now we are going to use the large language model again, OpenAI in this case, to do all the work with all these pieces that we have right now. So as you can see here, we pass in the question and we need the relevant chunks. Right, we are taking the relevant chunks that we created. We were able to query the database, right? And then we are passing that along in this with the question. So now we have the question, our question, asking questions about these documents, right? Whatever. And then now we have these only relevant chunks that were passed through the large language model, and the large language model now has more information or more knowledge of what we want to get the answer from, right? And so that is what's happening. So here I'm creating the context. Essentially, I'm getting these relevant chunks and joining in with other stuff. And then I have a prompt here, a prompt for our large language model to say, hey, this is what you need to be aware of when you are answering these questions. You're an assistant for question answering tasks. Use the following pieces of data, blah, blah, blah. Retrieve context to answer question. If you don't know, please say, I don't know, and things like that. Now, prompt is actually its own thing, and you have to be really good at prompting to get the right result from large language model. And then, of course, we pass that context and the question. We need to pass those two things, right? So now the large language model will have the question that we're asking, we typed in, and then we'll have the relevant documents because we've parsed that through already. You see? Okay. And then we call the create again. We go to the client, chat completions, and create, of course, the actual. Now we are going to the actual model. Say, hey, here's the information. Go ahead and give me the answer. That's all we're doing here. Okay. We pass in the prompt and as well as the question, and then we get the answer. This is what this will return. So now it's time for us to check out to see how this will work. So now I'm going to have here this query that I'm going to start doing here. So here, example, question. Tell me about AI replacing TV writers in strike. Now I know this question that would work because in one of these documents here, we talk about AI replacing jobs and so forth. And so I'm going to see if this works. So here's what's happening. I have the question and I need to get relevant chunks, right, from the document, in this case from the database. Well, I call the query documents and I pass the question. So it's going to go ahead and query the documents that are in a database, finding documents that are relevant to the question that we're asking, which is this here, right? And once we get these relevant chunks, we're going to need that along again with the question, the first question, and the relevant chunks we got to get the answer. Right? Because this generate response here, this is what we just talked about, is going to go ahead and pull in the context, relevant chunks, as well as the question, create a prompt, and then pass that through that prompt, and then call the large language model to then answer that question, and we get that answer. Okay, let's see if this works, and then we're going to print the answer here. All right, let's run this again and see if this works. So you're going to go through the whole process, of course. It will generate everything. And one thing also in the beginning, of course, we'll go through the process, but once you run once, because we'll have that data and everything, we should be able to just comment out the first part of this code essentially. So everything is good. But in any case, everything will still work, should work, because we have that data already. The other thing you will notice is that now we should have, you can see now we have this Chroma persistent storage, which is indeed the Chroma SQLite 3, which is the database that we created. This is the actual Chroma database. Pretty cool indeed. Okay, so we have that set up. So this will take a little bit, of course, Okay, now it says retrieving relevant chunks, and voila. It says here, TV writers are currently on strike due to the Writers Guild of America demanding regulations and the use of, on the use of AI in writers' rooms. So the Writers Guild, blah, blah, blah. So all of this information actually pertains to the articles that we have here. So AI replace TV writers. If I click here, you will see that indeed I should have something related to that. Let's see. Okay, regulate the use of AI, non-clear work, and so forth. So it goes ahead and looks at the correct other ones here that relate to exactly that. So for instance, I can go ahead and ask something else. Let's see. Let's say something about Databricks. Okay, so let me say, tell me about Databricks. And let's go ahead and go through the process. It went through the whole process, inserting chunks into DB, blah, blah, blah. It went through all of that. We know that. And at some point, it went ahead and said returning relevant chunks. And then, of course, we hit the large language model and says Databricks is a data AI, an AI company that recently acquired Okera, blah, 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 and so forth. So just like that, we're able to take the information, our own data, in this case here, so this could be anything, our own data in this case, and we parsed all that through. We extracted everything. We created these little chunks of this data, and then we used OpenAI API to actually create the embeddings. That's very important. And then we save that into a vector database. This is very important also. This is not a normal database. This is a vector database. And then we're able to search that vector database according to the question that we're passing through it. And then we got the right chunks, right? And then we pass those chunks of documents and the question and pass that through the large language model. And then we're able to get the answer. This is the power, as you see here, because now we're able to take our own data and sort of inject into the large language model so that we are able to ask questions about our particular data. And I hope you can see so many use cases that you can use this particular RAG system here to help you with analyzing data and so forth. All right, so I hope this was helpful to you. If you like this content, if you like this video and you're excited, you like to learn about large language models, AI-based applications, let me know so I can build or create more content towards this realm, this topic for you. If you're not subscribed, please go ahead and subscribe, because that will help this channel continue to grow. And always leave a message. I love to hear what you think, what you thought, what you want me to cover next. And thank you so much for your time. Till next time, be well.